Hi everyone. The goal of this video is to analyze some 3D shapes, and we'll talk about why as we go through the video. We're going to start with some vocabulary and just get to know all these shapes so when we study them we can use the same language. So the first types of 3D shapes we are going to study are called polyhedrons. And a polyhedron is a 3D shape with polygon faces that are joined by sharp vertices. In other words, a polyhedron cannot have any curved surfaces. No curved surfaces. Please write this definition down and any definition as we go through the video. So these are some examples of polyhedrons. None of them have any curves or circles. They're joined by polygons, so like this one has squares, you see triangles, I see a hexagon. They have sharp vertices, which a vertex is just where two sides meet. When it says it's sharp, it means there's like an angle there. It's not curved. Those are polyhedrons. Now the first type of polyhedron we're going to study are called prisms. And a prism, you may have heard this word before, but for a formal definition, a prism is a 3D object with two parallel, congruent, aka identical bases. Identical or congruent bases. Okay, the sides are some type of parallelogram. The ones we look at will typically be rectangular sides. And the shape is named by the shape of its base. So let's unpack that here. Make sure you have that written down. Okay, the first example can have two names actually. This is a cube to be specific. But really what you can also call a cube is a rectangular prism. Okay, because a square really just is a rectangle, special kind. Okay, whereas this next shape is a triangular prism. You see triangles there. Triangular prism. And the last shape you see here we would call a hexagonal prism. And this is where I said the shape is named by the shape of its base. So the base of this particular prism, for example, would be the hexagon shapes. And you know which one the base is by which two shapes are parallel. So you see, if you can kind of look through the shape, these two hexagons would never intersect. They're parallel to one another. So those are the bases, and it's named by the shape of the base. So what type of prism is this? We'd say a hexagonal prism. And the bases are always congruent or identical, so they're the same size and shape. And then we see the sides are parallelograms. So the sides are rectangles in this case, which is what we typically see. Whereas a triangular prism has two parallel triangles. So it's named for its bases, but still all of the sides are parallelograms or rectangles in this case. Again, this last one is a cube. If these sides were rectangles or the bases were rectangles, we might call it a rectangular prism. But since all the sides seem to be squares, a cube is probably the best word for that. The next kind of polyhedron we're going to talk about are pyramids. And there are a couple types of pyramids, but in general, a pyramid is a 3D object with triangle sides. Not rectangular anymore, but triangular sides. And they would meet at an apex, and the base is a polygon. So let's get that written down and unpack what types of pyramids we have here. If you need to pause and write, go ahead and do that. This one we'd call a triangular pyramid. And like our prisms up here, they're also named for their base. So the base is a triangle, and then we're going to call it a triangular prism. Whereas this one would be a rectangular pyramid. Okay, so the base is a rectangle or maybe even a square, and we'll call that a rectangular pyramid. Okay, again, they're named for their bases, but the vocabulary you see here is that all of the sides are triangles. So that's what's different than a prism over here, is that all the sides are rectangles. And this one only has one base. So the base is whatever it basically sits on. So like this one sits on a triangle, that's why it's a triangular pyramid. Whereas this one sits on a rectangle, so it's a rectangular pyramid. Then you see this word apex. Apex is where all the sides meet. So all these triangles come up to this point here. This is called the apex. Or on a rectangular pyramid, this is called an apex. The last type of 3D shapes are non-polyhedron 3D shapes. And remember we said a polyhedron has to have polygon sides and sharp vertices. These are not polyhedrons because they have curved surfaces of some sort. So the definition, I'm not necessarily going to give you, it's just like not a polyhedron, but I'm going to talk about what these shapes are. And these should be somewhat familiar, so I'm going to go through them quickly. But the first one is a cone, basically a curved surface that has a circular base. This is a sphere. And the last one is a cylinder. Okay, so the cylinder will have two circular bases, whereas the cone will only have one. Now the question of the day is, why are we talking about these names? You do need to know the vocabulary, but there's a bigger picture here. And that bigger picture is we're about to talk about surface area, and we're about to talk about volume. So surface area is basically the area of the outside. I know this is a really official definition, but you get the idea. The outside of a 3D shape. Okay, now when I say the outside, it's like if you were to wrap a present, how much wrapping paper would you need? Okay, or you can say it what covers the shape. Again, these aren't precise definitions, but it's just to get an idea of what surface area is. So I'm going to look at an example, and the good thing about surface area is there's a general idea that if you know that idea, you can pretty much find the surface area of any of these shapes. And that idea is any of these 3D shapes can be unfolded into a series of flat shapes. Let me show you what I mean. So let's take a look at this triangular prism, for example. Okay, here's an example of a triangular prism. It's just going to turn on its side. So you see here's a triangle base, the other one will be back here, and then all of the sides are rectangles. So that's a triangular prism. If I unfold the shape and just look at what's on the surface of it, it looks something like this. So on the surface, you've got those rectangles, you have those triangles. So there's 3 rectangular sides and the 2 triangular bases, and there we have our triangular prism, except it's flattened. And the surface area is what covers the shape. So if I wrapped in wrapping paper, how much wrapping paper would I need? So in order to find the surface area, I can really concentrate on what does it look like if it was flattened. So a triangular prism, like the one I've drawn here, will look something like this if I flatten it. I've got 3 rectangular surfaces. So the one is the base, and then there's a side over here and a side over there. So if I open those up, here are my 3 rectangular sides. Okay. And then the bases are attached to that rectangular side, and they're triangles. So it's going to look something like this if I unfold it, which is what you kind of saw in the simulation here. So going backwards, fold it back up, there's my triangular prism, and there it is unfolded. And if I want to find the surface area of it, I'm really trying to figure out how much area is on the outside of the shape. So all you would really have to do is say, okay, what's the area of each of these individual shapes that make up the triangular prism? So going back to surface area, it's the area outside of a 3D shape. It's what covers the shape. I always use the wrapping paper example. So how much wrapping paper would you need to cover a present, for example? And in order to find surface area, you're just going to find, I guess step 1 is find the area of each face. And a face is just the shapes that surround it. So like one of the faces would be this triangle. That's a face. This rectangle is its own face. This one's its own face, so on and so forth. And then add up the area of all the faces. Add area of all faces. Okay, so surface area is not really a new topic. I mean, if you know how to find the area of a triangle, a rectangle, a hexagon, a trapezoid even, I could give you a trapezoidal prism, then you can find the surface area as long as you're able to visually flatten that shape out. So just for one more example, let's say I took this cylinder here. It's one of my favorites. How does that flatten out? And you kind of have to visualize it, but you definitely have 2 circular bases because they're parallel bases. And then how does this unroll? Well, let's take a look. So if I open up those 2 lids of the can and then I unroll the can, it's actually going to wind up looking like a rectangle. So in order to find the surface area of a cylinder here, you could find the area of the rectangle, the area of each circle, and just add them all together. And that's how much would cover either the can or, you know, if you're not talking in context of the shape. And I'm just going to sketch what that looks like here. So you have 2 circular bases, and then the thing around them kind of wraps out into a rectangle here. So that's what the flattened out version would be. And just for another vocab word, this flat version is called a net. Okay, a net is just a flat version of a 3D shape. I'll use that word a lot this chapter. Okay, so if you know how to find the area of circles, you can find the area of a cylinder. If you know how to find the area of triangles, you can do a triangular prism. But it all takes visualizing, which is a really important mathematical skill. So what I'm going to have you do after this video is you are going to go to my website and find this interactive. So if you go to my website, we're in chapter 7, and under videos you see surface area visual interactive. You're going to click that, and you're going to draw me a net for all the shapes I didn't. So a cube, a hexagonal prism, the 2 pyramids, the cone, and the sphere. Okay, so I want you to use that interactive to help you, or you can Google it if you're not sure, or you can just visualize. Like if I unwrap this, what would it look like? And this will help us move on to how do we find and calculate surface area. I hope you took notes on everything I had to say, and thank you for listening.